So today is a big review of ratio and proportion. We're going to be solving some proportions and setting up ratios in the next lessons. And it's very important that you remember how to do this. So let's recall the definitions. A ratio is a comparison of two quantities, and it can be written three ways. A in this semicolon B, A over B, which is what we use most of the time, and some people write A and the actual word to B. So a proportion states that two ratios are equivalent. So if you take a look at what we have here, we have that A over B is equal to C over D. And remember, in the past, to solve these, if you had an unknown, you had to do cross multiplication. So remember, for cross multiplication, this would be C times B, and this would be A times D. Okay, so let's do some examples and see what we can remember. So it says, example 1, solve each. So A is a very straightforward proportion. We want to use cross multiplication. So we're going to multiply x times 5, and x times 5 is just 5x. Then we're going to multiply 3 times 75, and 3 times 75 is 225. Now, to get our x isolated, all we have to do is divide by 5. And once you put that in your calculator, you get that x is 45. Very simple, straightforward. Now let's look at B. B is just a little bit more complicated. We actually have algebraic expressions involved, and we got to remember some of our properties. So we're going to do cross multiplication again. We have negative 13 times 4. And negative 13 times 4 is negative 52. And this, we got to be really careful. We've got 2 times the quantity, 3x minus 5. Don't just multiply 3x. So it was pretty easy to go ahead and multiply the 13 and the 4. But here, we've got to use the distributive property. So we've got 2 times 3x, which is 6x, and 2 times negative 5, which is negative 10. Now we've got to solve this equation. So if we add 10 to both sides, we get that negative 42 is equal to 6x. And then lastly, divide by 6. And we get that negative 7 is equal to x, or x is equal to negative 7. So make sure that you do not make this mistake right here. You've got to use the distributive property. So let's move on to another example. Example 2 says, write the appropriate ratio. So we've got some words coming up in here, which we all love word problems, right? A says, a baseball player had 8 hits in 10 games. Find the ratio of hits to games. So hits is going to be in the top, and games is going to be in the bottom. So we're going to have hits over games. And we've got to find this information from the problem. So we have 8 hits, and we have 10 games. And you always want to write a ratio in its simplest form. 8/10 can be reduced. They're both divisible by 2. So we have 4/5. That is our ratio of hits to games. B says a hockey player played 12 games and scored 14 goals. Find the ratio of goals to games. So we want goals in the top, and then games in the bottom. We got to be careful here. It's written backwards in the problem. Your goals is listed second, and your games is listed first. So don't let that trip you up. We have 14 over 12, and both of these are divisible by 2, and you get 7 over 6. So that is our ratio of goals to games. Okay, let's do an example. Here's example 3. It says a model of a building is 6 inches tall and the actual building is 15 feet tall. If a doorway on the model is 4.5 inches tall, how tall in inches would it be in real life? Okay, so we've got some different measurements here. We've got 6 inches, that's equivalent to 15 feet tall. We have 4.5 inches, and we want to know how tall it is in real life. But if you take a look, we've got feet here. We need to convert this feet to inches. So there are 12 inches in a foot, So we have 15 times 12, and we get 180 inches. That's how tall in real life that building is. So we're going to create a proportion. We've got to have a ratio. So we're going to have the model over the real. That's how we're going to set it up. So for what we do know that the model is 6 inches tall and the real is 180. So now we are looking for how tall the door is in real life, because the real's on the bottom, but we know that it's 4.5 inches tall on the model. So here is our proportion. So we need to cross multiply. We got 4.5 times 80. 180, excuse me. And you get 810. And then we have 6 times x, which is 6x. And divide by 6. And we get that the door is actually 135 inches tall. We don't know if it's garage door, we don't know what kind of door it is, but we do know that it's 135 inches tall.